Hello everyone, I hope everyone is safe and doing good. Welcome back to my channel Trick or Treat with Mathematics. So far we have seen different concepts of functions. I have introduced you the definition of function along with in detailed explanation about range, codomain and domain of a function. If you haven't watched my previous videos on these topics yet, I will link the playlist up here for you to watch so that you'll understand these concepts before we jump into today's video. So today's video is all about types of functions. In today's video, I'll be covering especially one function in detail, that is one-to-one function or injective function. Along with that, I will also help you understand the pigeonhole principle that is related to one-to-one function. If you are new to my channel, hi, I'm Deepthi. Welcome to my channel. This channel is all about mathematics. So I'll help you solve all the maths problems that you will face during your examination, several examinations for that matter, fundamentally by helping you understand the basics and the foundations of those concepts. So if you haven't subscribed to my channel yet, please hit the subscribe button down below and hit the bell notification so that you'll get a notification as soon as I upload a video. So now without wasting any more time, let's jump right into the video. Now, what is a function? I have covered this topic in depth in one of my previous videos, but you will definitely know by now what is a function. A function is that if there are elements in A and there are a few elements in B, then every element in A should have a unique image in B. That means this is like this is like this, you can say this and you can say this. This is a function, right? So if you define something like this, for example, if this is A, this is B, A, B, C, D, E, F, G, and if you say, is this a function? No. Why? Because here B has two images, F and G, which is wrong. It should only have one unique image as per the definition of function, right? So how do you define this relationship now? This element and this element can have the same image as well, right? In this case, we have these two elements that has the same image, but these two are not, like this is not pointing to two images here as of this case, right? So how do you define this relationship? Can you say that more than one element in A can have the same image? Yes. So more than one means, can you not say this as many to one? Right? And so what is this? Is this a function now? Yes. So can you not conclude that many to one relationship is a function? Yes. But here, you are saying the relationship here as one element is mapped to two images, which is wrong. So you know for a fact that this is not a function, but you also know that one element here is mapped to two elements here. So what kind of relationship do you think this is? Can you not say that this is one to many? So in short, can you not say that to many relationship at all is not a function and many to one relationship is a function based on this? Right. Now, if I ask you another relationship, say for example, this is A, this is B. Now A, B, C, D, E, F, if you say this is the mapping, what is the difference between this and this? Here you have two elements in A mapping to exactly one element in B. Here you have one element in A mapping exactly to one element in B. Am I right? So, what is this relationship based on this knowledge that you have? Can you not define this as one-to-one? So, this is a one-to-one relationship. So, this is also a function because it's not going away from the definition of function. It's still valid. It's saying that one element in A will have one image in B. One element in A is mapped to exactly one element in B. So it is a kind of a function, but the relationship is one-to-one. Hence, this is called as one-to-one function or injective function. This is the difference. You need to understand this difference. If, for example, if you say this is the codomain, okay, if you say that this is the codomain and this is A, here also you are saying this is the mapping that exists. It's still a one-to-one function? Yes, because you are not bothered whether all these elements should fall under the range or not. You are just bothered that the mapping that exists between A and B is such that each element in A will have exactly one element mapped in B. One corresponding element mapped in B. That is called as one-to-one function. Okay, so this is what we call as one-to-one relationship or an injective relationship. So how do you define the one-to-one function formally using this explanation? A function is said to be a one-to-one function or an injective function if and only if f of x is equal to f of y. That implies x is equal to y. Or conversely, we can say that if f of x is not equal to f of y, then x is not equal to y. These are the definitions or mathematical definitions of one-to-one or injective function, which means that in short, all the elements in the domain, if you say for example this x and y, all the elements in the domain x will have different images in y. That's it. So this means all the domains, all the elements in this domain now, it has different images, right? D, E, F. Is there a difference in different images in y? Yes. So that this is the mathematical representation of whatever we have discussed till now. So this is a one-to-one function or an injective function. Now let's see how do we put this in a graphical form so that you'll understand the difference between a function, not a function, and a one-to-one function. So these are the three graphs that I drew here just for you to understand the difference between a one-to-one function and a normal function. You know for a fact that using the vertical line test method, you can understand whether a particular graph is a function or not, and you also know how to determine the domain and range of a function. These two I have covered in my previous videos. Now, if you see these three functions or these three graphs, which of the following do you think is a function, which of the following is not a function, and which of the following is a one-to-one function? Let's start with this first graph. Here you can observe that one value in x-axis has two values in y-axis, right? Say for example is 1 and 5, right? This is just a graph of a curve, and you can see for a fact that one value x in x-axis has two values in y-axis. That means if you consider x as the domain, we all know that x is the domain and this as the range, then you know for a fact that this one value in the domain cannot have two images, right? So that means one value here is mapped to two values, 1x as 2y, right? So that means, do you think this is a function? No. So this is a graph of not a function. This is not a function graph. Okay. Now if you see this graph, here there are two values of x, 2 and 4. And you know for a fact that from this graph you can see that these two values are mapped to only one value. That means this representation, don't you think it is like this? And this is still valid, right? This is a definition of function only. You just need to make sure that this 2, if there is any 4, this 2 doesn't have two values, right? But in here we don't have this possibility. We only have two values mapped to only one y. So hence you can say that this is a function. Yes, and if you draw a vertical line also, it's cutting only in one point. So this is a function. Right. Now coming to this graph. If you see here, this is a y is equal to x graph, and one value in x-axis will have one value in y-axis. Same here, one value in x will have one value in y. So this is not a typical case of one-on-one or one-to-one. Right, so this is a typical case of one-to-one. Here we have 2, 4, and here we have how much? 2, 4 only. 2 is mapped to 2, 4 is mapped to 4. Right, so this is a typical case of one-to-one function. Am I right? So, can you not say that this is an injective function? Yes, because all the elements in the domain are mapped to different images in one. Right. So, this is an example of an injective function or one-to-one function. Okay. So, this is how you determine whether a graph is a function or not a function or a one-to-one function. Alright. So, if you observe the one-to-one function, right, this graph here, or you can also say any strictly increasing function where there is no bump like this. Right, it's a strictly increasing function wherein strictly increasing function always have f of x is greater than f of y. So, any strictly increasing function or strictly decreasing functions are the examples of one-to-one function or an injective function. That is what you need to keep in mind. So, whenever you see a graph in your exam and if they ask you to determine which type of function it is, or if you determine the type of function, it may help you solve the problems related to graphs as well. Right. So, whenever you undergo such situation, if you see a strictly increasing or a strictly decreasing function, you should definitely identify that it is an injective or a one-to-one function. Okay. So, this is how you differentiate between a function, not a function, one-to-one. So, now let's see a quick example of an injective or a one-to-one function. So, I'll give you that there is a function such as 4x minus 1 where f is a function from R to R. You need to tell me whether this function is a one-to-one function or not. Per definition of one-to-one function, you know that for all x1, x2 or x5 whatever you take, f of x1 is equal to f of x2, which indicates that x1 is equal to x2. Right. So, these x1 and x2 will in this case will fall under the real numbers because the domain of this function is real numbers. So, if you assume x1 and x2 are some real numbers and if you try substituting x1 in this function, we'll get 4x1 minus 1, and if we try substituting x2 in this function, do we get 4x minus 1, 4x2 minus 1? Right. So, the next step is what? Equating this. So, equate these two functions. 4x1 minus 1 is equal to 4x2 minus 1, and if you cancel both sides, you will get x1 is equal to x2. Are you getting x1 is equal to x2? Yes. Hence, it is a one-to-one function. And the graph of this will look something like this. If you draw a line like this, right? Say for example, this is the graph, it will look like something like this. It will be x1, x2, f of x. Okay, this is the graph. That means this value in the negative x-axis will have one negative y-axis value, and this value in the positive x-axis will have one positive x-axis value. So basically, in short, there is one-to-one relationship here between x and y. Okay, so this is how you define or you show that a function is a one-to-one function or not. I will give you another example and you need to tell me whether that function is a one-to-one function or not. Okay, so the other example would be if there is a function that is from R to R, f of x is equal to x square. Do you think this function is a one-to-one function or not? The graph of this will look something like this. It's a parabola. Okay. This will be the graph. But what is f of x is equal to x square in general? Let's now use the definition of one-to-one function. You know for a fact that if x1 is equal to x1 and x2 belong to R, for all x1 x2 belong to R, there exists f of x1 is equal to f of x2 such that x1 is equal to x2. What is this function first of all? It's a square of a number. So, for example, if you take x1 is equal to 2, what is f of x1 in this case? You get 4, right? And if you take x2 is equal to minus 2, what is f of x2 in this case? What do you get? You get it as 4, right? So that means, what are you observing here? If you take the values of x1 and x2 and 2 and minus 2, that means two different values, you are getting one image. That means you're getting this relationship. But this is not one-to-one, right? Right. And you know for a fact that the square of a number is always positive. But the domain we have given here is R. That means all real numbers. That means if you substitute all negative real numbers, you will get a positive value. And if you substitute all positive real numbers, you will get positive numbers only as the output. So that means there is no differentiation between negative and positive. Because it's a square, it's a positive function, it's an even function. So in that case, can you say that this is a one-to-one function? No. And if you put this here, if you say this is minus 2 and this is 2, you'll get this value as 4. So you'll be having 2 values of x for 1 value of y. Hence, this is not a one-to-one function, rather than this is just a function. But if you want this function to become a one-to-one function, what will you do? If you just put plus here, that's it. So all positive real numbers is the domain of the function. In that case, the graph will become somewhat like this. They will not be negative in scope. This will be the graph, and you will get the value of 2 here as 4. That means you are substituting all positive numbers to get all positive numbers only as output. That means there is one-on-one relationship, there is one-to-one relationship, right? So whenever these 2 real numbers are positive real numbers that does not include negative values, then this function will become an injective function. If not, if they just give you a function f from R to R without specifying whether these are positive real numbers, then this function is definitely not an injective function. Okay, so this is one more example that you need to keep in mind in order to define an injective function. This will be frequently tested. Okay, so you understood this, right? x1 is 2 and x2 is minus 2. If we substitute here, we'll be getting 4 only as value, right? So that means, however, you can say that x1 is not equal to x2 in this case, so 2 is not equal to minus 2. So this is not a one-to-one function if we take the domain as all R and not positive R. Okay, so now let's see an interesting concept of pigeonhole principle, and the underlying foundation of that principle is one-to-one function. So now what is a pigeonhole principle here? Pigeonhole principle states that whenever there are n pigeons, okay, and there are m pigeonholes, these are n pigeons and m are pigeonholes, but n is greater than m. That means number of pigeons is greater than number of pigeonholes. Then there will be one hole that has at least 2 pigeons in it. That means, for example, let's take there are 5 pigeons and 4 pigeonholes. These are number of pigeons and these are number of pigeonholes. In this, there are 4 holes, right? Now, if you want to accommodate 5 pigeons in 4 pigeonholes, what will you do? First, you put all the 4 pigeons in one hole, like in 4 holes, all the 4 pigeons in 4 holes, right? So, 1 pigeon here, 1 pigeon here, 1 pigeon here, 1 pigeon here. And how many pigeons are you left out with? 1 more. So, what you need to do in order to fit this pigeon in these holes? You definitely have to put it either here. You need to put it either here or here or here. If you say this as A, B, C, D, then you need to at least accommodate this remaining pigeon in one of these pigeon holes so that you can fit all these pigeons into their respective holes. Right. So what are you seeing here? The principle is the consequence of one-to-one relationship. So the relationship between the pigeons and pigeonholes is definitely not one-to-one is what you are observing here. Whenever there are n pigeons and m pigeonholes, wherein n is a finite set and m is a small finite set than n. So if this is a small finite set and this is a finite set, and wherein n is greater than m, That means a function from a finite set to a small finite set cannot be one-to-one. It can be a function, it's just a normal function, but it cannot be an injective function. The relationship cannot be one-to-one, and you can see here as the example. Here if you say A, B, C, D, E as the number of pigeons and 1, 2, 3, 4 as the number of pigeonholes, then if you try to map each one to one, then there will be at least one pigeon that is left out. In order to accommodate this, you need to map this at least to one of these pigeonholes. That is the pigeonhole principle. The importance of this principle is that it's widely used and implemented in many combinatorics problems, the permutation, combination, arrangement problems, and this principle is widely used for programming as well. So it is imperative for you to understand this principle so that you can apply this wherever you encounter a situation wherein you can apply this principle. It's very interesting and extremely important. So this is all about one-to-one function or injective function, and we have seen the pigeonhole principle. I hope you understood the concepts taught in this video so far. So if you have any questions, please leave a comment down below so that I will be able to help you. So I hope you understood this video, and I request you to please like, share and subscribe to my channel and ring the bell notification down below so that you will never miss an update from me. In the next video, we'll see a few more types of functions, but until then, I request you all to be safe, stay happy and enjoy the rest of the week. Bye.